class, to our lesson. We are continuing the second part of our lesson. In this lesson, you say we are describing the categories of questions that we have in physics and giving examples showing how to answer them. You are talking about statement questions where we give facts as they are. Most of the time we state laws or principles or give factors or conditions, facts. Descriptive questions where in form of a paragraph you illustrate a process, like how to find the thickness of a page of paper. Then we have comparative questions. In the comparative questions, we talk about contrast. Use the words like why, whereas, but to show difference between one thing and the other. The next bit that we will talk about are the numerical questions or mathematical questions, and then graphical questions. Then we come to an end. So, in the case of numerical question, the example that we did look at last time will serve well. You are told that perspex is a form of transparent plastic. It has a refractive index of 1.5. A ray of light strikes the flat surface of a perspex box, block, in an angle of incidence of 40 degrees. What will be the angle of refraction? So we have a medium here. This is perspex, and this is air. Then we do have what we call the imaginary normal. Imaginary normal. So a ray of light incident to the perspex will be refracted. This becomes the angle of incidence, while this becomes the angle of refraction. In this case, we are told that this one is 40 degrees. Now, we need to know about Snell's law, which states that the ratio of the sine of angle of incidence to the ratio of the sine of angle of refraction between two same media is a constant. The angles may be different, but the ratio of their sines will be a constant. So with this in mind, you end up working out this question. Because what we've been given here is the angle of incidence, we have been given the refractive index, we can calculate the angle of refraction using this formula. The refractive index is sine I over sine R. And that means if we do a cross multiplication, sine R is sine I over the refractive index. Sine I is sine of 40 degrees divided by 1.5, and you get our answer, which will be the sine of R. That will be the sine of R. Of course, having the scientific calculator makes your work easier. So, sine of 40 divided by 1.5, I get to be 0.4285. I don't need to get sine R. I need to get R, the refractive, the angle of refraction. So R shall be the sine inverse of 0.4285, which if I work out with my calculator, shift sine inverse, I get to be 25.37 degrees, approximately 25 degrees. So, how do we deal with mathematical questions? Read the question, understand it, see the values that have been given to you, then use the appropriate formula. In this case, this was the appropriate formula. Refractive index is sine of I over sine of R. Use that appropriate formula, manipulate it about, work it out, find sine R, substitute the values given, get the sine inverse, and get the angle. Simple and straightforward. Then let's finish with graphical questions. Graphical questions are such that you have what you call a vertical line, y-axis, horizontal line, x-axis, and on the vertical line we have the dependent variable, on the x-axis you have the independent variable, unless otherwise stated that you do the reverse. So in the question that we have here, we are told that to use an illustration, describe the cooling process of matter from gas to solid. Now we talk about what we mean by the heating curve and the cooling curve, showing this change of states of different forms of substances. So in this case, on our y-axis we have the temperature, degrees Celsius. On our x-axis we have the time in seconds or minutes. So let's say we're talking about water. Water vapor will be at 100 degrees Celsius. For a while it cools. There is no change in temperature, but it is changing from steam to liquid water. That should be OA. At point A, it has completely changed to liquid. Lowering temperature means loss of heat, so it will lower in temperature up to a point where freezing occurs. That should be point B up to point C. Freezing process ends, all of it will be turned into solids. So temperature will be lowered, but it's already a solid. And that means this is condensation, lowering of temperature. This is freezing, turning into solids. This one turns into liquid. Then this one, lowering of temperature as it's already in solid form. Time is independent. Time is not controlled. It is on the x-axis. Temperature is dependent. It is controlled by time. It is on the y-axis. This is y and this is x. That's how the graphical questions are, and you can have all sorts of answers from there. So in this lesson, what have we looked at? We have looked at what we call statement questions. Give the law, principle, rule as it should be. Factual form statement. We have looked at descriptive questions where you give your answer in a paragraph, and it helps if you can have a diagram as well. We have looked at comparative questions where you have to show differences. So use words like why, but, where, as to show that this is like this or that's like that. We have looked at numerical questions which are mathematical in nature. Identify the values given, identify the formula to use, substitute the values given, and you find what you're looking for. Sometimes though you may have to use more than one formula to answer question. Then we have looked at the graphical questions. The example is still here, where you have the independent variable on the x-axis, independent variable on the y-axis, or vice versa if you have been instructed. Draw or illustrate what should be happening, and you can describe the changes or can work out a few things from these changes. As always, read your notes, read your textbooks, revise, try to understand as much as possible, and then practice. Answer questions at the end of the textbooks, revise from your past papers, and then you will excel in physics as always. So see you next time in the next lesson.